So when you're thinking diamonds, at least for me, I think about diamond cutting tools, and most everybody knows about that. But I'm here at SP3 today with my buddy Brett to figure out where else, Brett, can we use diamonds?
Well, there's a lot of applications where diamond can improve a product. Diamond is known as a super material.
Okay.
A lot of people know it's the hardest material there is,
Yeah.
but it has a lot of other extreme properties. It's also the stiffest material. It has extreme wear resistance.
Okay.
It's extremely resistant to chemical attack and etching.
Yeah.
It has the highest thermal conductivity of any material. It makes a great heat sink. And so there's a very large number of properties that makes diamond very special.
Yeah.
And a lot of our customers will want to use one or more of their properties to enhance their product with a diamond coating.
Okay, well, it makes a lot of sense then why it's so good on cutting tools. But so you start out by asking where. So do you guys put one type of diamond on things, or what does that look like?
So the types of diamond that we typically do are microcrystalline diamond, MCD, and nanocrystalline diamond, NCD.
Okay.
And both of these are polycrystalline diamond types. Most people are used to single crystal gemstones,
Yeah.
but you may remember from elementary school growing rock candy crystals.
Oh.
This is a good example of a polycrystalline material where you can see the different crystal grains all in different directions, randomly oriented,
Yeah.
but they're all overlapping and grown together into one solid material.
Okay, but your diamonds aren't that big,
There,
are they?
our grain size is between 1,000 and 1,000,000 times smaller than these crystals.
All right. So very, very small. So cutting tools, we know why they're working so good for cutting tools. What other applications are you using right now with your customers then?
So we talked about wear resistance.
Yes.
There are pump seal applications where they have the facing surface coated with diamond.
Yeah.
And this gives extremely good wear resistance.
Okay.
If you're, say, in oil and gas, doing fracking, working with very abrasive slurries.
Yeah.
And it also gives a very long lifetime to the components so that you don't have to replace downhole equipment or very critical pumps.
Yeah. Well, and downtime is the most expensive thing because we can't manufacture more time. So if you can save these companies downtime
Yes.
on pumps, or I'm guessing some of these other things look like they might be pretty critical too. What's this? What's this one over here?
This is a die for drawing different materials,
Okay.
and they are constantly getting worn out. And diamond's going to give you the longest lifetime, give you the ability to hold tight tolerances for the longest amount of production volume.
So again, extending that uptime, keeping these companies being productive by taking advantage of the technology you've developed here at SP3. So what about this one over here? What's that about?
This is known as a CMP pad conditioner.
Okay.
And in the semiconductor industry, they will use a CMP process many times when they're building an integrated circuit. It will flatten out the silicon wafer so that they have the exact same device in the center as on the edge and improve their yield.
Well, and then all those special characteristics, the toughness, the hardness, all of those things is going to make sure that that diamond, that sanding disc stays uniform, so you're not getting a taper or anything.
Day after day, it's always the same, reproducible, and meeting the tight specs.
That is really cool. Okay, there's one more I gotta know more about, man. What is this?
This is a very special type of diamond coating this titanium mesh. It's called Boron-doped diamond, BDD. So by adding a small controlled impurity of boron to the diamond crystals, we can actually turn it into a semiconducting material. And so you can push electrical current through the diamond film while it's still very chemically resistant.
That is wild. I don't know a lot about electricity, but I know normally you push electricity through something, you start to have a reaction with the oxygen, and your thing wears out very, very quickly.
Exactly. That's a problem with a lot of electrodes.
Yeah.
And for long-term operation is in applications like wastewater treatment.
Yeah.
You're going to want to have an electrode that lasts a long time. And we found that the diamond electrodes can actually be used to destroy the PFAS, the forever plastic chemicals in water.
We don't have to drink microplastics anymore?
Not with boron-doped diamond.
That is so cool. Now you got a big one. Can I even pick that up? Because that looks...
Yeah, so we can coat semiconductor wafers.
Wow.
This is a wafer with a diamond coating that is surrounded by an edge ring that also has a diamond coating.
That is so cool. It looks very fragile.
Oh,
right
it is.
now.
It is. When they manufacture silicon wafers, they have to etch the circuit features in, and that ends up etching all the materials in their reactor and will have to eventually be replaced, leading to downtime. By coating some of these wear parts with diamond, we can drastically increase the lifetime and reduce downtime, increase productivity.
Well, man, I know we're going to get into the technical details a little bit more about how you guys make all of this possible, but it's really clear to me, Brett, after listening to you, that if there's an application where you're wearing out and it's causing you downtime, diamonds might just be the answer.
Yep, absolutely. It's a super material.
Awesome. Well, thank you so much, Brett.
All right, thank you.